Hello math students, it's Mr. Ray here. We're going to be learning our first grade 10 lesson today, which is multiplying polynomials. So before I get into the lesson, it's really important you know the terminology. And I put out a previous video for the review, which was from grade 9, talking about math as a language. And I talk about this in more detail, the terminology. So if you still don't know the difference between what a term is, what a variable is, what a constant is, what an expression, what a polynomial, what a equation is, if you don't know the difference, you really should go back to that video and make it crystal clear. I'm going to do a quick little review to get ready for today's lesson, but it's a really good idea to have those terms, those definitions of what these things mean very, very clear. So the topic today is called multiplying polynomials. So just as a brief recap, polynomial basically means many terms, and a polynomial is the same as what we would call an expression. So an expression and a polynomial are basically the same thing, and you'll be hearing both used back and forth. Before we talk about this, what is a term? Just a reminder, term is when you multiply constants and variables together. For example, negative 3x squared is a term. It could be any combination of any type of constant with one or more variables. It could involve just one variable, two more, and we could also be multiplying that variable one or more times. For example, here we're multiplying x twice, x times x. Okay, now what a polynomial or expression is when we take different types of terms, and we add or subtract them together like several times. It could be once, could be 5, 6. Most of the time we're going to be working with polynomials that are 2, 3, sometimes 4. Okay, so that would be a term plus or minus a term, plus or minus another term, etc. Okay, so when we talk about polynomials, there's different ways of classifying polynomials. This is very important. This is from today's lesson. The first way, let me finish writing this. The first way is by the number of terms. Okay. So that's based on, I just said we had polynomials. You could have any number of terms being added or subtracted. So if you have one term, for example, if you just have a single term like that one, we call that a monomial. So one term is called a monomial. If you had two terms, if I just added say a plus x here, negative 3x squared plus x, that would be two terms, and we call that a binomial. And for three terms, if we had, say, negative 3x squared plus 2x plus 5, that's three different terms. You can always tell by the plus and minus signs in between the terms. You can add them up. If we had three terms, that's a trinomial. Okay, now there's other names for 4 and 5 and 6, whatever. We're not going to learn those specific names. So for example, if you had, for our case, so if you had n terms, so n is, more than 4. Sorry, more than 3. If you had n terms, we just call that an n-term polynomial. So you don't have to memorize, even learn the other names. So for example, if I had a polynomial that had 7 terms, I just call that a 7-term polynomial. Okay. Now you could call a 3-term polynomial sorry, you could call something that's 3 terms a 3-term polynomial, but I do want you to, instead of calling it that, I want you to call a 3-term polynomial a trinomial, and these other ones as well. Now, these prefaces here, mono, bi, and tri, those are big hints. Mono means one, like monorail, mononucleosis. Bicycle for bi. Biped means you have 2 legs, so bi means 2. Triceratops, tricycle, tripod, that means 3. So if you ever forget, try to think of, maybe another word that starts with that, and that should trigger what that means. So that's the first way of classifying. Okay, the second is by the degree. Okay, so the best way to talk about this is, if I give some examples here. So the degree is basically the exponent of the variable. It's a little bit more than that, but that'll get you in the right direction. So if I had, I'll do some examples here. If I had, let's start with a single term, like a monomial. So if I had 3x squared, that would be degree 2 because of the exponent. Okay, if I just had 3x, well, you're saying, well, there's no exponent there. Is that 0? No, there's actually kind of an implied one, which means we just multiply x one time, but we don't usually put the 1 there, but it's there. Just like if I said x, that would be 1x. Okay, so x by itself, really there is an exponent of a 1 there, so that would be degree 1. What if I just had a number, which is possible? The number 7, if it's just a constant and there's no variables, that means since you have no variables, you have no exponent. So it's a degree 0. Okay, so let's, those were monomials. We just learned about monomials as one term. What if I give some examples with two terms? So say I had 5x to the 5th plus 2x cubed. Okay, so when you have more than one term, and each term might have a variable, so what you have to do is you have to look at each term and say what the degree is, and then you just pick the highest of all the terms for the polynomial degree. Okay, so for example, this tells me this is degree 5 for that term. This tells me this is degree 3. So overall, that polynomial is degree 5. So definitely don't add them up. You just pick the highest degree term that's in there. Okay, so that should make sense. What if you start using more than one variable? So for example, say I had 13x squared y plus 2y squared. Okay, so again, we look at the maximum degree, but what happens when you have more than one variable? So in this case here, we have x's and y's in the same term. So what you do is that's an implied one because it's just y. You add up the degrees within the term. So degree 2, degree 1. So overall this would be degree 3. This would be degree 2. So now you pick the highest of the two, so that this would be, for the polynomial overall, this would be degree 3. Okay, so hopefully that makes sense. So if I put this all together, I could give you a polynomial. Let me make this a little tougher. So example, 26x squared y to the fifth minus 3x cubed y squared minus 7.2, throw in a decimal there, x to the fourth. Okay, so if I asked you to classify this, and you will see these, you know, on a test or a quiz. So if I asked you to classify this polynomial, okay, so the first thing you do is we want to know how many terms there are. So remember, the easiest way to figure out how many terms is to separate based on the plus and minus signs. So if I'm reading through here, okay, there's a minus sign. Read through, there's another minus. So basically I've got 3 terms. Now if I put the break before the sign, I've got each term very separated. So this is definitely a trinomial. I'll add that at the end here. Now, if I want the degree, hopefully this is a little easier now. So if I want the degree of the first term, so I'm adding up the exponents of all the variables. So that's 2 and 5, that would be degree 7. So I'll just put a little 7 up there for my to keep track. Degree 3, degree 2, add them together, we get degree 5. And that's just 1, so that's degree 4. What's the biggest one of all of them? That's 7. And it is possible to have a tie, and that's fine, just pick that number. So this would be degree 7 polynomial, because this is the highest. So I would say degree 7. And remember we said this is a trinomial, so I'd say degree 7 trinomial. And that's how you would classify any polynomial, by first of all by the number of terms and also by the degree. And if you put them together, this nice little phrase tells you a lot about the polynomial you're working with. Now we have a special name. If I go back to these examples for the degree, anytime we have a degree 2 polynomial, this is exactly, we have a word for that, just like we have a word for the 1, 2, and 3 terms when we classify. If we have a degree 2 polynomial, we call that a quadratic. And we're going to spend the better part of this course talking about quadratic polynomials or quadratic expressions. Could be 1, 2, 3 terms, but this is a very important term for the rest of the course. Now, we also have a word for us, a degree 1 polynomial. We call that a linear. And you remember in grade 9 we did this, talked about these types of expressions a lot. So degree 2 polynomials are called a quadratic, and a degree 1 polynomial is called a linear expression or polynomial. Okay, so there's the background. Hopefully that makes sense when we start doing subsequent lessons. Okay, so if I go to the lesson note, a lot of the stuff I've just covered. So the degree of polynomial, the degree of the greatest degree term. So remember, you took each term, figure out its degree, and then you take the biggest number of all the terms. And that's the degree of the polynomial. Quadratic expression, remember this is a second degree polynomial. We call that a quadratic expression. And then polynomial is an expression with when you're adding and subtracting terms, and it could have any number of terms. It can also have a single term, which would be called a monomial. If you had 2 terms, it's called a binomial, and a 3 term is a trinomial. Okay. Now, before I do, we're actually going to learn how to multiply 2 binomials, now that you know what that means. But this should be a very quick review. So if you're multiplying 2 monomials, you say, for example, I had 3x squared times negative 2x. Okay, if I'm multiplying these two, and anytime you have brackets, side by side with nothing in between, that means multiply, and you'll see that more and more. We don't tend to use multiplying signs all that often from grade 10 onwards. They're still there occasionally, but you're going to see it written more like this. So 3x squared times negative 2x. So when you're multiplying two terms or two monomials, so the first thing you do is you look at the you look at the constant part. So I'm just ignoring the x parts. I'm just saying, okay, what's the number part of each of these? I got a 3 and a negative 2. If I multiply those two together, I'm going to get a negative 6. So I write that because this is going to be the number part of the answer. And now I can ignore the numbers and just look at the variable parts. So in this case, I have x squared times x. So remember, when you multiply two terms, two variables with different exponents, what we do is as long as the two variables are the same, in this case it's an x, so I know I'm going to have an x, and then to get the new exponent of this, you add the two exponents together. So this is really a 1, so when I add these together, 2 plus 1 is 3. And a lot of students will forget that and just multiply and put a 2 there. That would be wrong. So think of it this way. An x squared actually means x times x. And an x means just x. So if I'm multiplying x times x times x, I'm actually going to have 3x's multiplying, or x to the power 3, or x cubed. Okay, so when you're multiplying your variable parts, remember you're adding the exponents of the like variables. Okay, so on to the lesson. So we just did an example of multiplying two monomials. I guess I should maybe do this time a monomial times a binomial, because you've done these before. You probably didn't call it this. Okay, so let's do this. 3x times x minus 2. Okay, so it's pretty easy to see those are two monomials, right? Because there's just one term, nothing separated by a plus or minus. Well, there's a minus here, but it's not separating two terms. It's just the sign of one of the terms. So now in this case, you can see this clearly is one term, and this is two terms because we have x and a minus 2 or negative 2. So in this case, it's going to be a little different. So what I usually like to do is draw some arrows. So this 3x is multiplying with this whole x minus 2. So you could say, well, it's multiplying with each part. So first of all, I'm going to multiply the 3x with the x, and then I'm going to multiply the 3x with the negative 2. So if you write this out in the long version, you don't have to. You could say, I'm going to multiply the 3x with the x. That's the first arrow. And then I could put a plus sign here because I'm going to now multiply the 3x with the minus 2. Okay, you might say, well, why did you put a plus there? Why not? The minus that's in there is incorporated within the term that you're multiplying. So it's probably better you put plus between your multiplications and then figure out the sign from the multiplication part. So now you basically, remember bad math, you do the multiplications first and then you add. So in this case, this is monomial times binomial. So we got a 3 times 1, x times x is x squared. So we're done that. Now here we have a 3 times a minus 2. So this would be your minus 6. So now I would put a minus sign there. And here we have an x in this term but not in this term. Well, if that's the case, you just leave it as the single x with exponent 1. So that's how you do monomial times monomial. Okay, now we're going to learn how to multiply two binomials together. And there's actually, I'm going to show you two ways of doing it. And you can use whatever way you want. I'll tell you the pros and cons. So first of all, we're going to use something called FOIL. So this would be FOIL over here, and this will be what I call matrix. You're going to see a lot of similarities, but slight difference in the terminology. So what does this word FOIL mean? Well, it actually is an acronym, and it stands for first, outside, inside, last. I could spell. Okay, so it's just a memory tool, and you'll see how this works in a second. So I'm going to start with the original question, x plus 2 times 2x plus 3. And you can see pretty quickly that that's a binomial and that's a binomial, so we're multiplying two binomials together. You can only use this FOIL technique when it's multiplying two binomials. The matrix technique can be any number of terms. So you could have multiply two trinomials together. So matrix is a little bit more, you could extend it to some harder questions. A lot of people learn with the FOIL first just because it's a little memory tool. So let's see how that works. So the first thing we do is we follow the instructions from FOIL. It says the F stands for multiply the first terms together. So that means that these two terms, x and 2x, are the first terms. So I could show that with an arrow here. That's the first. I could write it out as a multiplication first. Okay. So that takes care of the F, the first. The outside are the outside two terms. So the first and the last. So the first term of the first expression, binomial, and the second term of the other one. So you can think of outside as the outside two terms. So that's going to be, and I always put a plus sign to start. That means I'm multiplying the x with the 3. Okay, I might need a second line here. And now the inside, you can see the inside is going to be the two terms that are the inside of the four terms. So that's going to be plus 2 times 2x. Okay, I'm running out of room, but I'll just add the last part here. So that was the inside, 2 times 2x. And then the last are the last two terms in both. So the 2 and the 3. So multiply 2 times 3. So we basically, there's our first multiplication, our outside multiplication, our inside, and our last. You'll always have 4. Now, do you have to do it in that exact order? Not really, but it's probably recommended, and I'll explain in a minute. So if we actually multiply, so what we've got now is we've changed this into 4 multiplications of multiplying two monomials together. So this should be fairly straightforward. X times 2x, that's 2x squared. X times 3 is plus 3x. Remember, we put the constant first. 2 times 2x is 4x. And then 2 times 3 is 6. Okay, so these have been multiplied, no more brackets. Now you might think we're done, but if you look in the middle here, we've got two terms that are the like terms. And when I say a like term is when you have the same variable in both terms, or those terms, to the same degree. So even though that's also an x, that would not be like term to these guys, because that's exponent 2. These are both exponent 1, so they have the same thing in common, these guys. So I can actually simplify that to the final version. I'll keep the 2x squared the same, And when I add these two together, it's like I have 3 x's and I'm adding it with 4 x's. Well, that's a total of 7 x's. And then the plus 6. Now you can't go any further than this. None of these are like terms. Okay, that's because they have different variables with different degrees. X squared, x, and no variable. So this would be your final answer. Now, I mentioned earlier about, do we have to do it in the same order that the acronym, the FOIL thing says? You don't have to, but if you look at it, it comes out nicely in this order, so that when you write it, it goes from highest degree term to lowest degree, and it also puts the two like terms together in the middle, so they're easy to spot and combine in your final step. Okay, so let's show you the matrix method. So a matrix, it's kind of like a little table. So what I do for FOIL is you just do like a 2 by 2 table. So 2 rows and 2 columns. And then I go back to the question. I go, okay, the first expression was x plus 2. So I'm going to break those two terms apart. I have an x. I'll put that on top of the first column, and I have a plus 2 as my second term there, so I'll put that on top of there. And then I look at the second binomial, 2x plus 3. I do the same thing. I split those apart, and I put those on the columns. Now it doesn't matter at all. I could have put the x plus 2 here and the 2x plus 3 here. No difference. Well, it'll look different, but the end result will be the same. So now what you do is, what I'm going to write in each of these cells is basically, for example, this cell here is going to be multiplying that row with this column. So this will be 2x times x. So 2x times x is 2x squared. Okay, and then here would be 2x times plus 2, so that's going to be plus 4x. Down here it's going to be positive 3 times x, that's plus 3x. And finally plus positive 3 times positive 2. And then we're done. So all I do now is, this is the tool to get my final answer, is I just start listing off all these 4 together. But before we do that, if you notice on this diagonal here, I've got 2 like terms. I got 3x and a 4x. So when I write this out, I'm not going to write them separately. I will combine them together. So I always kind of start at the top left. So I have my 2x squared from here, and then from these two cells I've got plus 7x, and finally at the bottom my plus 6. And if you notice, it's exactly the same answer. The other thing I want to point out is the four mini results we got in the matrix were the same values that we had over here from FOIL. Okay, so a lot of this is similar. It's just kind of a different perspective or approach to looking at the question. I also mentioned that the matrix would be good if you wanted to multiply, say, a trinomial. So the way you could do that would be something like this. Say I had, this is a side example, say I had a trinomial, something like 2x squared plus 3x plus 1, right? So there's your trinomial, and I multiply that with x minus 4. So now, instead of having 4 cells, when I had binomial times binomial, now I have 6. And again, each cell is just multiplying the row with the column. And then you're going to see that you actually have common or like terms in those 2 sets. We won't do it, but I'm just showing you you can actually extend this model to multiply any types of polynomials together. Okay, so that's how we multiply 2 binomials, and you can actually use either method. Pick the one that makes most sense to you, and use that. Now I've got some examples we're going to go through here. Now I'm going to use FOIL for this, but obviously if you prefer the the matrix approach, you could do it that way. Okay, so remember it's first, outside, inside, last. So I'm going to draw my arrows just to show what I'm multiplying. That would be x times x. You don't have to do this every time. It's good to start off this way. So that's first. Then we have outside. So I put a plus sign, then x times 5. Then the inside, 2 times x. And then the outside, sorry, the last would be these two here, 2 times 5, positive 5. So now you just, now like I said, you don't have to do this step. You could be going along going, oh, x times x, that's x squared, and just write what I'm going to write here. X times 5, that's positive 5x, 2 times x plus 2x, and then 2 times 5 is 10. And remember, we have to simplify, meaning combine the like terms. So in this case, it's going to equal x squared plus 7x plus 10. And that's our final answer. And if you did it using matrix, you would get the same result. Okay, so for these last two examples, I'm not going to write the first line, but it's really just repeating, just putting out what you're going to multiply first. So I've kind of given myself less room here. So first would be x times x, that's x squared. So I'm going to skip that first step. Then we have outside, maybe I'll do it this way. Outside there, x times positive 4, that's plus 4x. And then the inside would be here. That's negative 2 times x, negative 2x. And then finally the last, negative 2 times 4, that's negative 8. Okay, and again, you've got the two middle terms that can be combined because they're like terms. So that's, when you're combining these, you're really just adding the exponents. Once you know that you've got the same variable to the same degree, you know you're going to have an x. What's in front will be the sum of the coefficients, the number parts. So that's 4 minus 2, that's plus 2x minus 8. Okay, so that's that one. And then this one here, this one's a little trickier because we got a 3x instead. So it's going to be 3x times x first, outside 3x times negative 5, that would be negative 15x, and then inside positive 7 times x plus 7x, and then, sorry, that's not right, the last would be positive 7 times negative 5, that's negative 35. Combine these two guys together, 3x squared, so this is like negative 15 plus 7, or 7 minus 15, that would be negative 8. Just let me double check what I'm doing. Negative 8x and minus 35. So that would be your final answer there. So hopefully this is making sense, the FOIL method or the matrix method, depending on your choice. And you could basically do any two binomials. So we're going to up the level of difficulty here. So we're going to expand and simplify, which basically means we're going to multiply and combine like terms. So this time we've got two binomials, but we have a constant out front, and you can always put that constant in brackets to make it clear to yourself that you're multiplying. So what do you do now? You know how to multiply these two. So here's where you have a couple of different ways of doing it. Now, here's what you don't do. This is a very common mistake. You don't multiply the negative 2 with both of these first, and then do a FOIL with what you have left over. So here's your two most common choices. A lot of students would just say, okay, let's just do the FOIL here. Once we get our answer for that, then we multiply what our answer from the FOIL was by -2. So that's good. It's a good choice. Another thing you could do is first just multiply the -2 with the 4x minus 5, see what you get, and then whatever you got from that, you multiply with 7x minus 6 using FOIL or matrix. So what I'm going to do is I'm going to leave the -2 up front. I'm going to put these big square brackets, which will be the result of this FOIL here between the 4x minus 5 and the 7x minus 6. So this time I'm not going to put my arrows. Hopefully you can follow along. So the first would be 4x times 7x. So the number part, that would be 4 times 7, that's 28. And x times x, that's x squared. So that's the first. The outside would be 4x times -6, so that's -24x. That's the outside. Then the inside, -5 times 7x. So that's -35x. And then the last would be -5 times -6. Well, that turns into +30. Negative times negative. Now, I want you to simplify what's in here first before you multiply. I see lots of students will multiply all these. Now, you know that you've seen so far that the two middle will usually simplify, combine into one because they're like terms. So I prefer you do it this way. Don't multiply by -2 until these are combined. So that's -59. So it's -24 minus 35. That's -59x plus 30. Okay, so now this has been simplified inside. So now we can go ahead, multiply each one of these by -2. So that's really just affecting the number part. The variable part doesn't change. So that's going to be -2 times 28, -56x squared. And -2 times -59, that turns to +118. And it's an x, so you're noticing these variables aren't changing. And then -2 times 30 is -60. And that is our final answer. So just as a recap, we first just did the FOIL on the two binomials, kept that inside the square brackets. Once we've got that simplified, then we multiply by -2. So be consistent. Don't just leave out the -2 and bring it back in. Okay, you have to. When you put an equal sign on each of these, you're saying this is the same as this, which is the same as this, which is the same as this. If you start doing bits and pieces of your multiplying, that's not good math form. It's actually wrong, because if you leave stuff out and bring it back in, these won't be all equal. Okay, here's another one. This looks really tough, but if you look at it, we kind of already did this first one type where you had a constant times two binomials, and then we've kind of added on a subtraction of two binomials. So remember your bed mass, okay? So what we're actually going to do is we're going to figure out this part, and we're going to figure out this part, and then we're going to combine them together. Okay, so we're going to leave out the, I'll just show you what I mean by that. So we're going to leave out the 2 here, and then we're going to multiply x plus 7x minus 3. So let's do that kind of in our head. So first is x times x. Outside is x times -3. Inside is 7 times x. And last is 7 times -3. Okay, now we're going to put a minus sign and then another set of square brackets. The brackets are really important. If you don't put brackets here, you're going to have a wrong answer for sure. So inside, now we're just looking at doing this. So 4x plus 3 times 2x minus 1. 4x times 2x, that's going to be 8x squared. That's your first. The outside, 4x times -1 is -4x. Inside, 3 times 2x is plus 6x. And last, positive 3 times -1 Okay, so we've basically done 2 foils, but we still have to simplify, because if you notice, we've got 2 like terms there, 2 like terms there. Let's simplify first. Okay, so we have a -3 and a +7, or 7 minus 3. So that's going to be plus 4x minus 21. Yeah, so keep the brackets for now. 8x squared minus 4x plus 6x, that's going to be plus 2x minus 3. Okay, so now, like we did on the previous one, now I'm going to multiply the 2 with each term in here. This is really multiplying a monomial with a trinomial. So it multiplies with each of these 3, so that's doubling. So I'm going to get a 2x squared plus 8x. So remember, you're just affecting the number part, not the variable part. And 2 times -21 is -42. Now, this one's a bit tricky, and this is why it's important to keep your brackets here, because the subtraction is applying to everything inside here, not just the 8x. And if I forgot to put those brackets on, I'd only be subtracting one of them and adding the other 2. So we don't want that. So there's a few ways of thinking about this. One way is just to say, well, I'm subtracting each of these separately. So let's do that, and then I'll talk about the other method. So if I subtract 8x squared, that's just subtract 8x squared. If I subtract 2x, that's just subtract 2x. And if I subtract -3, well, now the sign changes, right? So it turns into a +3. Okay, so that's how first we just thought about subtracting each of these, what it really means. Another way you could think of it is if I'm subtracting something in brackets, I'm basically flipping all the signs from what they were to their opposite signs. So for example, this 8x squared changed to minus 8x squared, this 2x changed to minus 2x, this -3 changed to +3. Okay, so that's another way of thinking. The third way, and these are all the same really, just different perspective, you could imagine if you had a 1 there, which you do, and you're basically multiplying each of these by -1, which is really the same as flipping the sign. So those are 3 ways of thinking about it. Now the very last thing we're going to do, because we have 6 terms here, but you can see we have lots of pairs of like terms. We have a couple of x squared terms, a couple of x terms, and a couple of constants. So now we just combine the like terms together. So 2x squared minus 8x squared, well, that's 2 minus 8, which is minus 6x squared. Then we have 8x minus 2x, that's plus 6x. And then -42 plus 3 is minus 39. So this is your final result. Not quite as many steps as you might have thought when you first saw the question, but once you get good at the FOIL, you can do it pretty quickly. Once you get to grade 11 and 12, you probably just go from multiplying a binomial to the final version where you've combined the like terms in your head as well. Okay, so there's some questions here. I'd like you to try those out, get really good at multiplying binomials, and even some tougher stuff here. So we're going to continue on. The next lesson will be multiplying special cases of 2 binomials. It's a shorter lesson, but just some special cases of multiplying 2 binomials together. All right, have a great day.